Now recording. Okay. So we are here Thursday the 18th. So I'm doing more related rates, do some more related rates. Maybe I'll just start giving you the formulas for 310 and 311. Okay. Tomorrow we'll have a quiz. It'll only be on the exponential growth and decay section. Okay. So that'll be tomorrow's quiz. So stuff like we did yesterday, which would have been 3.8. Okay, so questions like 3.8 for the quiz tomorrow. All right. Now there are formulas for sections 10 and 11, even though I'm not going to lecture on sections 10 and 11 very much until next week. I might sneak in a little bit of 3.10 tomorrow, but I want to at least show you all the formulas by tomorrow. So, I don't want to wait until Wednesday for you to see a formula for the first time. I'd rather give it to you, even if I'm not lecturing on it. At least you can have it prepared for your cheat sheet in preparation for the test next Friday. Okay. So if I have time today, I'll do that even today to just show you, okay, this is what you need. This is what you have to put in your formula sheet, even though I may not be lecturing on it for a while, but at least you see ahead of time, okay, here's all the formulas. I'll dump all the formulas on you so you can at least put them down and have them ready for the test next week. Okay. And let's see, let me check the chat. Some of you just joined. So yeah, I'll get you later. Okay. So, and some of you are asking, did you call me for row? I always call everybody. So if you didn't catch it, you came late because everybody else knows I go down everybody. If anybody isn't there, I call their names out a second time. And if you don't believe I do that, you can ask anybody else who's there at 9:10, and they know I do that. I double check that. So if that ever happens, just go ahead and put your name in the chat and I'll get you for attendance later. Okay. All right, so that's where we're at. Okay, so quiz tomorrow on exponential growth and decay. Again, planning for the exam. This will be our largest chapter for the exam on the 26th. That's the day just before the spring break. Again, so we don't meet again until April the 5th. So it's a nice time to have it, I guess. And again, Thursday the 25th, I'll reserve for questions and answers. If you have any questions about anything, bring it up on that day. And you submit for homework all of chapter 3, which is our biggest chapter. As you can see, 1, 2, 4, and 5 are not as big. So we're doing all derivative shortcuts. It's long. As you know, there's a lot of formulas, but you can put them all on your formula sheet. And you should be thankful that you don't have to do, for the most part, limit h approaches 0, f of x plus h minus f of x all over h. I had to do that. I had to show it to you where the formulas come from, but for the most part, you aren't responsible for them anymore until I tell you to, which is probably the final exam where you might have to do another one of those. Okay. All right, so let's continue on with where we were. Let's see, for the in-class yesterday, some of you are asking how it worked. So area is pi r squared. I realize you have to type pi on your keyboard. So dA dt is 2 pi r dr dt. I know it looks clumsy when you type 2 pi r, almost looks like pure or something like that, unless you put parentheses around it to separate it. But if you were able to write it, which of course you'd be allowed to do on a quiz or homework or test, you would write it like this. So dA dt is equal to 2 pi r dr dt. Okay, so that was the in-class yesterday. If you got it wrong, don't worry. You didn't gain or lose any points from it. I wanted you, once in a while, when I give you these quick in-class things, I want you to try it without the pressure of, quiz or test or points. But the only thing I don't like is if you don't submit something, then that might count negatively against you, against your participation. Okay, and that you should at least try. Okay, so you shouldn't just type in 0. Right? Somebody got the idea. Oh, he wants me to put something down. So no matter what he says, I'm going to put 0. So this in class, I'm going to put 0. Next in class, I put 0. Next in class, he said you got to put something down. So I'm just going to automatically put 0 no matter what it is. That's not giving at least a good try, right? So some of you did not have this. I get it. That's okay. You did not lose points, but you are going to lose points if you just keep writing 0 on all these in-class assignments, right? Because I don't like that. Obviously, I want you to try it. Okay, so these aren't graded except for, I want to see that you tried And if you don't, if I see a pattern that you don't submit it, even though you supposedly showed up for attendance, then I don't like that either. Okay, so I just want you to try it without the pressure of, I got to get it right or I got to get it wrong or whatever, right? Okay. All right, so that's that. So let's get back to where we were on related rates. Okay, so related rates started on page 245. Okay, remember the way it works is every variable for related rates needs a d variable dt. You differentiate with respect to t. Okay, so I did a bunch last time and I'll do more. Okay, next one I want to show you is 19, which is kind of similar to when we did earlier. Okay, so 19. A man starts walking north at 4 feet per second from a point P. 5 minutes later, a woman walks south at 5 feet per second from a point 500 feet due east of P. At what rate are the people moving apart 15 minutes after the woman starts walking? Okay, so I can't really show you both at the same time that well. Okay, but if you look here, okay, so P and Q, I put P and Q. The man is starting at point P and goes north. So I put an arrow up 4 feet per second. Okay, and then the woman starts 5 feet per second south, 500 feet due east of P. Okay, so the man's here, the woman's here, she's 500 feet away, and she goes south 5 feet per second. And not only that, she starts 5 minutes later, I think it said. Right, 5 minutes later. At what rate are the people moving apart 15 minutes after the woman starts walking? Okay, so I can't show you both at the same time, but I'll give you all the essentials right here. Okay. All right, the other thing I noticed is that they mix up more than one unit of time. They have seconds and minutes here. So number 19, I see 4 feet per second, 5 feet per second, but it says 5 minutes. Okay, so you probably should know if you're doing any one problem, you need to keep the same unit throughout. So in other words, you don't want to mix up, meters and feet or hours and years in the same problem. So I see minutes and I see seconds. So I either change everything to minutes or I change everything to seconds. Okay. Now, if I change everything to minutes, it'd be a little bit clumsy. For 4 feet per second and 5 feet per second, you have some fraction or decimal. So I'd rather not. Okay, so I'd rather change everything to seconds. Okay, so I see 5 minutes. How many seconds is 5 minutes? 5 minutes, how many seconds? Well, 1 minute is 60 seconds. So therefore 5 minutes multiplied by 5, right? So 300 seconds. All right. All right, here's my picture. Okay, so the man is going 4 feet per second upward, 500 feet. Woman's going 5 feet per second down. Okay, I'll call this X and I'll call this Y. Okay, the distance between them, which is moving, I call it Z. Okay, and then I drew myself a right triangle like so, where this is Y, this is X, this is 500. Z is this distance here. Okay, and we're asking for the rate of change of the distance between the two. That's dz dt. Okay, so I call that hypotenuse distance Z. At what rate are the people moving apart? So on the picture, I've got a Z, 15 minutes after the woman starts walking. Okay, that is dz dt, rate of change of the distance between them as time goes by. All right, other things I have here. So 5 minutes later, I mentioned that's 300 seconds. Okay, the problem says 15 minutes after the woman starts walking. Okay, So 15 minutes, 15 times 60 is 900 seconds. So she walks for 900 seconds. The man had a 5-minute head start. So he's actually walking for 20 minutes. Right? 20 minutes times 60 is 1,200 seconds. So here are all key pieces of information. Okay. Right, so 5 feet per second, 900 seconds, 15 minutes. So the woman walks for 4,500 feet. The man is 4 feet per second for 1,200 seconds. It's 4,800 feet. Okay, and again, it'd be a lot better if I could show you both at the same time, or you can refer back to the text. But here's what's going on again. Okay, man is here, woman is 500 feet due east. Man goes north, woman goes south. I'll call that Y, I'll call that X. 5 feet per second for 15 minutes, it says. 15 minutes is 900 seconds, 15 times 60. Okay, so 5 feet per second times 900 seconds is 4,500 feet. The man walks for 20 minutes because 5-minute head start. 20 times 60 is 1,200 seconds. 4 feet per second times 1,200 seconds, 4,800 feet. Okay, this is the hypotenuse. Do my Pythagorean theorem. Okay, this is X, this is Y. So X plus Y squared plus 500 squared is equal to Z squared, right? X plus Y squared plus 500 squared is Z squared. Okay, the distance from here to here is X plus Y. We figured out X was 4,500 feet. Y was 4,800 feet. Add them up, 9,300. Okay, this distance is 9,300 feet. 4,500 plus 4,800. I drew this picture in order to get my right triangle. So A squared plus B squared equals C squared. 9,300 squared plus 500 squared is equal to Z squared. So Z is the square root of 9,300 squared plus 500 squared, roughly 9,313.43. All right, so now I need my formulas for related rates. So my Pythagorean relation is X plus Y squared plus 500 squared is equal to Z squared. There it is, X plus Y squared plus 500 squared is equal to Z squared. Okay, X plus Y, 500, Z. Okay, so now I differentiate with respect to T, related rates. So 2 X plus Y to the first power, then by the chain rule times the derivative of the inside with respect to T. Dx dt plus dy dt. Plus the derivative of 500 squared is 0. 500 squared is 250,000. It's a constant. Derivative of 0 equals 2z dz dt. Okay, so one more time, 2 parentheses X plus Y times by the chain rule dx dt plus dy dt plus the derivative of that is 0, 2z dz dt. Okay, divide both sides by 2z. 2's cancel out. Divide that by z. So dz dt is X plus Y over z times dx dt plus dy dt. These are all plugins. What is dx dt? Rate of change of x with respect to time. The rate at which the woman's walking, 5 feet per second. Dy dt, the rate at which the man is walking, 4 feet per second. Everything else is a plug-in. That's a 5. That's a 4. X was 4,500. Y was 4,800. Z was 9313.43. Okay, so 4,500 plus 4,800 divided by 9313.43. The whole thing times 5 plus 4, which is 9. Okay, it's about 8.9 feet per second. So my answer is roughly 8.9 feet per second. Okay, so you can see there's a lot involved in some of these problems. Okay, so come up with a relation, then differentiate with respect to time, meaning every variable needs a d variable dt, and then solve for whatever you need to. Just start plugging in all the other stuff. Okay, I'll raise this up a little bit so you can see it better. Then all my calculations. Okay. All right, next one I was going to show you was 21. One there. Page 250. The altitude of a triangle, that's the height, is increasing at a rate of 1 centimeter per minute. Okay. Instead of altitude, I'll call it the height. So that's dH/dt, rate of change of height with respect to time, dH/dt. The area of the triangle is increasing at 2 centimeters squared per minute. Okay, that's area divided by time, dA/dt. Okay, and sometimes when you just look at the units, if you analyze the units, you can tell what to write. Right, that's a height, that's a time, so dH/dt. Centimeters squared, that's an area, that's a time, dA/dt. And then the question is, at what rate is the base of the triangle changing? dB/dt is what we're looking for. Rate of change of the base with respect to time. Okay, and they tell you stuff to plug in. The altitude, height, is 10 centimeters. Area is 100 centimeters squared. Okay, again, ideally, I keep this projected while I write on a whiteboard, but again, I can't do that, so I have to make the book disappear, and you just have to take my word that I wrote all the data correctly. So let's see if I can do that. Okay, so they showed us a triangle. They said the height is increasing. So the height's increasing at 1 centimeter per minute. That's dH/dt. dH/dt is 1 centimeter per minute. Then he said the area is increasing at 2 centimeters squared per minute. That's dA/dt. Then it says find the rate at which the base is increasing. That means find dB/dt. Okay. Again, so how do I know that's what they asked for? Okay, so if you can look at the words for 21, at what rate is the base of the triangle changing? The rate is not asking for the base, it's the rate of change of the base. Once you see rate, you know time's involved. So that's rate of change of base with respect to time. That's dB/dt. Okay, and they give you some data about the altitude and the area. Okay. So I'm trying to find dB/dt. All right, so they tell me the height is 10, area is 100. They did not give me the base, but I can figure out the base. Formula for the area of a triangle, 1/2 base times height. So I'll put 100 here, 10 here, ignore the red temporarily. So 100 equals 1/2 base times height of 10. Half of 10 is 5. So 100 equals 5b, b is equal to 20. Okay, so I deduced that the base is 20. They didn't tell me that, but based on this data and this data, I found that out. I don't need that to plug in. Okay, so I'll use the formula. Area is 1/2 base times height. Now, I could use that, but I don't like the fractions. That's why before I take my derivatives, I decided to multiply both sides by 2. I don't want to have fractions if I don't have to. So I'm going to rewrite the equation as 2a equals bh. Agreed? Which is really the same formula. When I start differentiating, I don't want all these fractions all over the place, right? Okay. You're always allowed to do that. Clean it up before you start if possible. So 2a equals bh. Okay. Now I differentiate with respect to time. Okay, so every letter gets a d letter dt. Okay, what's the derivative of 2a? 2 times dA dt. Right side's a product root. First function, second function. So here we go. First function, b, times the derivative of the second. What's the derivative of h? 1 times dH dt. Plus second function, h, times the derivative of the first, dB dt. Okay, and now I have everything I need. I'm solving for dB dt. I have everything else from the equation. I know dH dt, dA dt, B, H, and A. So everything just gets plugged in now. So from here, they told me dA dt is 2. You don't have to worry about the units. The units will take care of themselves, but your final answer, you should give proper units. Okay, maybe I should have said that ahead of time. dB dt, what are the proper units? Base is in centimeters. The time is minutes. So my answer is going to be blah, 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 centimeters per minute. Rate of change of the base with respect to time. Okay. 2 times 2 equals base. I figured out that was 20. Okay. Notice they did not give me the 20. I had to derive it. I had to figure it out from, that data and that data. They gave me the area. They gave me the height. Plug in the area as 1/2 base times height. I figured out that the base was 20. So 20 goes here. dH dt was 1 centimeter per minute. You don't have to put the centimeter per minute right now. The units will take care of themselves. Just put the 1. Plus h dB dt. And h was given to be 10. Okay. So 2 goes right there. 20 goes there. 1 goes there. 10 goes there. Solve for dB dt. Okay. So that means I've got 2 times 2 equals 20b times 1 dH dt plus h 10 dB dt. Solve for dB dt. All right, so 2 times 2 is 4. 4 equals 20 plus 10 dB dt, rate of change of base with respect to time. Okay, subtract 20. Negative 16 equals 10 dB dt. Divide by 10 and you're done. So dB dt is negative 1.6 centimeters per minute. Negative means it's actually shrinking. Okay, so in order for these conditions to be held, where dA dt, the area increases by 2 centimeters squared per minute, the height increases by 1 centimeter per minute, and at that particular moment in time, the base is 20, the height is 10, the area is 100. Okay, then the rate of change of the base is negative 1.6 centimeters per minute. So this thing's actually getting scrunched. It's moving inward as time goes by in order for that to happen. Okay, so that's the way that one works. Okay. All right, then 29 was the next one I was going to show you. It involves a cone. (29) Gravel is being dumped from a conveyor belt at a rate of 30 feet cubed per minute. Okay, maybe I'll just stop there for a moment. What quantity would that be? And you should be able to tell from the units, this thing down here, 30 feet cubed per minute. Feet cubed sounds like what? Minute sounds like time. So cubic is volume. Minute is time. So that's dV dt, 30 cubic feet per minute. So gravel is being poured on at the rate of 30 cubic feet per minute. So that's dV dt, rate of change of volume with respect to time. And its coarseness is such that it forms a pile in the shape of a cone whose base diameter and height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? Okay, so this conveyor belt is pouring sand, I guess, or whatever it is, or gravel. Okay, and the way it's being dumped, it turns out that this diameter, the diameter of this circle, matches the height always. Okay, I don't know if you can see that. Yeah, see how they put 2 marks there? Those are symbols from geometry. You might recall from high school geometry that if you put 1 mark and 1 mark, they're meant to be the same, and 2 marks and 2 marks, they're meant to be the same, and 3 marks and 3 marks, they're meant to be the same, right? In your high school geometry class. So that's the idea here. That diameter all the way across the circle matches the height. Okay, the pile is 10 feet high. How fast is the height of the pile increasing? So what quantity does that represent? Rate of change of height as time goes by. That's dH dt, rate of change of height with respect to time. So we're trying to find dH dt. All right, so I'll lose the book now. All right, so here's the picture. dV dt is 30 cubic feet per minute. You can even tell just by looking at this, right? The top is rate of change of volume. Volume is cubic, whatever. And the bottom's a minute, time. So find dH dt, rate of change of the height as time goes by. So we're pouring gravel on top. So as I keep pouring the gravel, the height will increase. What's the rate of change of that height? Okay, now it said this was the same as this. Diameter is twice the radius. Okay, so if it says the height is 10 feet, that means the diameter would be 10 feet also. So the radius is 5 feet at that particular moment in time. Okay, so diameter is the same as the height, it says. I guess that thing went like this, right? Let's see if I can duplicate what the book has. 2 marks, right? So diameter equals height, but diameter is equal to twice the radius. So if I replace D with 2R, 2R equals H, or H is equal to 2R. That means the radius is H over 2. Okay. All right, so now I take the volume of a cone. The formula for the volume of a cone, you may have seen that before in middle school, I'm guessing. 1/3 pi r squared H. That's the formula for the volume of a cone. If you need it, you can put it on your cheat sheet. Remember, for the test, you get 1 cheat sheet, one 8.5 by 11 double side. Okay, you put anything you want, and of course you can use a calculator. But for the test, that's it. No other books, no other notes. Can't use computer, laptop, Peepo, cell phone, or anything else. All right, so what I'm going to do is I'll substitute in. Formula for the volume of a cone is 1/3 pi r squared H, but R is H over 2, correct? So right here, I'm going to erase R, put in parentheses H over 2. See that? See that H over 2? That's the replacement for R. 1/3 pi R, there's R, right? H over 2 is R, squared H. So the principle, of course, of substitution. Anytime one thing is equal to another in any mathematical statement, you can replace one with the other. So if R and H over 2 are the same, anytime I want to, if I see an R, I can change it to H over 2. So instead of R squared, I get H over 2 squared. Okay. That way my equation only has H. All right, so if I square this, that's h squared over 4, right? H squared over 4, 4 times 3 is 12. So volume is pi over 12 h cubed now. Okay, one more time. This is h over 2 times h over 2, h squared over 4. So there's a 4 in the bottom, multiply that 3 in the bottom, I get 12 in the bottom. There's a pi, and I have h squared times another h, so that's h cubed. So I got my formula to be volume equals pi over 12 h cubed. Now I differentiate both sides. Okay, so dv dt, the derivative of v is 1 times dv dt, just put dv dt, equals pi over 12 is a constant, 3 times pi over 12, 3 partially cancels a 12, leaving me with pi over 4, h squared dh dt. And there we go. We have everything we need. Okay, so derivative of this is dv dt, derivative of this, pi over 4, h squared dh dt. In fact, this question is almost like the in class yesterday, question 2 that I had you guys do, right? Very similar. Okay, now I plug in dv dt was 30. H was 10. Okay, so I put 30 here, 10 squared. 10 squared is 100, right? Okay, so I'm going to put 30 here. I reached the bottom on my paper, so I got to go back up, but that's going to be a 30. That's pi over 4. This is going to be 100. So there it is. Okay. So 30 equals pi over 4 times 100 dh dt. 100 divided by 4 is 25. So 30 equals 25 pi dh dt. Trying to solve for dh dt. So I have 30 equals 25 pi dh dt. So get rid of the 25 pi. Divide both sides by 25 pi. And I have it. So dh dt is, let's see, 30 over 25 reduces to 6. So 6 over 5 pi feet per minute. And that's my answer. And that pretty much does it. Okay. Okay, so I'm actually done with 3.9. Okay, we still have 15 minutes. We'll probably finish a little early today. Let me give you the focus job again. So I'm raising this up so you can see it a little bit better in case it was blurry. So again, you can watch the video if you need to. And there's that. And some more there. And that. Okay. All right, and this linearization of a function, that's starting section 3.10. I'll show it to you again tomorrow, but I'll just, might as well just show you what we have here and what we're up against. Okay, so we have a few minutes left. Just show you where we're at. Okay, so I'm actually done with 3.9 now. So I'm going to go ahead and mark this off. So between now and the test, I just have 3.10, 3.11. So maybe tomorrow, well, of course, I have to give you time to do the quiz. So tomorrow and Monday, I'm guessing for 3.10, Tuesday, Wednesday for 3.11, and then Thursday, question and answer, and then Friday, the test. So I have 2 days for each section for now. But if I can finish earlier, that'd be great. Also, okay, so let's say for now, 3.10, 3.10, 3.11, 3.11, questions and answers, test, okay? All right, and as promised, I want to at least go ahead and show you all the remaining formulas so you can start putting them together so it won't be a surprise. Again, if I wait until next week to give you the formulas for 3.11, maybe that's not enough time, but at least you'll have everything. Okay, so what are the remaining topics for this super long chapter, right? So we're almost there. It's been a long chapter, right? Yeah, all the different rules, power rule, product rule, quotient rule, chain rule, right? Exponentials, logarithms, implicit differentiation, related rates, all that stuff. Okay, so what's left for 310 and 311? Okay, so 3.10, the topic on page 251, linear approximations and differentials. Okay, now linear approximation, we're sort of already doing that with the equation of the tangent line. Okay, so what do you want? Okay, 252. Now, what they have is correct, but I think you can survive without it. So number 2 might be useful. I said might be, but you can survive without it. It's called the linearization of f at a. It's a function. If you really want to know what it's about, remember when we set the equation of the tangent line? Y minus y1 equals m times x minus x1, stop. The linearization is written as a function, which means don't stop, make it look like y equals mx plus b. So in this section, when it asks for the linearization, you come up with the equation of the tangent line, okay, and then solve for y. So here, instead of leaving it as y minus y1 equals m times x minus x1, and then you may have heard me say, okay, you can stop now, and I'll tell you when you have to keep going. This is the now. This is now when you have to keep going. Make it look like y equals mx plus b. That's called the linearization as a function, L of x. Okay. Essentially, what we're doing is replacing the function, which presumably is harder in most instances. Maybe the original function has trig and logs and square roots and all kinds of messy stuff. We're replacing it with the approximation, a line. Why do we want to do that? We like lines. We like straight lines, right? They're very easy to compute, okay, compared to all kinds of functions. Okay, so I'm going to say you can put number 2, but it's in my mind, it's optional. You don't need it. If you understand the idea of y minus y1 equals m times x minus x1, solve for y, then you don't really need to take up extra space on your cheat sheet for number 2. Okay. All right, so let me see this. Let me check the chat real quickly. Yeah. Okay, exam is going to be 10 questions. Yeah, I'll still say roughly 10 or maybe 11. There's 11 sections, so maybe I'll give 11. But still, yeah, you just have the 1 hour to do the exam. Okay. Differentials on page 254. Number 3, yeah, you can have that. dy equals f prime of x dx. These are called differentials, tiny change in y, tiny change in x. You've already heard of delta y and delta x. So what's the difference between that and dy and dx? dy and dx are presumably the same, except they're quote unquote small. They're technically very small. So dy equals f prime of x dx. Okay. If we were meeting on campus, I'd make you memorize it, but it's really not that difficult. Here's one way you can remember it. Look over here. dy dx equals f prime of x, the Leibniz notation, right? This is a symbol for derivative. This is a symbol for derivative. Right? Pretend if you multiply both sides by dx. If I multiply by dx, that cancels out, right? And this would have f prime of x dx. So that's how I would make you memorize it. Again, a warning, your next teacher might make you memorize some of this stuff. To tell you that ahead of time. Oh, and by the way, speaking of the next teacher and so on, I did just find my schedule. I am scheduled to teach Calc 2 in the fall, from what I heard. I believe it's 8 in the morning, 8 o'clock to 9 o'clock, so an hour earlier than this semester. Okay, that's tentative. It can all be changed. So everything's changeable. But from what I heard for now, I'm scheduled to teach Math 252 for the fall daily, 8 to 9 a.m. Okay. And as far as I know, it's still going to be remote. I don't think we're going to meet on campus still for the entire semester. So just thought I'd let you know in case you think that works in your plans or you don't want me in your schedule, just so you know. So 252, 8 to 9 for fall 2021. Okay. Since some of you were asking about that. Anyway, so dy dx equals f prime of x. Pretend you multiply both sides by dx, and it looks like this. Okay, let's see, you don't need that right now. Again, so these are called differentials. Okay, differentials there. Okay, that's it for 310. Now, 311, there's a lot of formulas. They can get scary, so I'm cutting it down considerably. Okay, so I will let you know. 3.11 is on the hyperbolic functions. Okay, you say, I never heard of hyperbolic functions. That's okay. So that's why we're here to learn it. Okay, so on page 259, here's the definition of the hyperbolics. Okay. Again, if we were meeting face to face, I'd make you memorize it. Okay. Notice it's the 6 trig functions with an h at the end. Sine, cosine, tangent, cosecant, secant, cotangent, but they all have an h. H stands for hyperbolic. Okay. Now it gets real clumsy to keep saying it, but technically I'm supposed to say hyperbolic sine, hyperbolic cosine, hyperbolic tangent, hyperbolic cosecant, hyperbolic secant, hyperbolic cotangent. You can tell it's kind of hard to say that. Okay, so I make up my own stuff. I'll call this cinch. So if you hear me say cinch, there's an English word cinch also, isn't there? C-I-N-C-H. Cinch, so I'll say cinch X. That looks like cosh X, or some people say cosh. Either way, cosh or cosh X. Okay, I don't really know how to say this. You know, tan with a little H after it, maybe. Okay, these we don't have to worry too much. It's, you know, they don't happen that much, frankly. So I'd just go ahead and say hyperbolic for these, but they don't occur that much. This one kind of looks like cough, I guess. Okay, but in any event, the key ones are these two. So hyperbolic sine, e to the x minus e to the negative x over 2. Cosh is e to the x plus e to the negative x over 2. All of these obey the reciprocal rules just like in trig. Okay, so if I were to make you guys memorize it, okay, so I'm just going ahead and say, yes, you can put it on your cheat sheet, but I would say, okay, for cinch and cosh, they both have e to the x, they both have e to the negative x, and they both are divided by 2, right? So it's easy to memorize if you think of the similarities, right? E to the x, e to the x, e to the negative x, e to the negative x divided by 2. Then I had a memory trick. My memory trick is the sign gets the minus sign. You know, it sounds the same. So sine gets the minus sign, therefore cosh gets the plus. So I would tell my class, and you guys are my class now, so we were meeting face to face, I would say to you guys, okay, they both have e to the x, they both have e to the negative x, they're both divided by 2. Sine gets the minus sign, so minus plus. Okay. And then if you've memorized the trig rules, you got all the others. So hyperbolic tangent is sinh divided by cosh. So that divided by that, you might recall that if you have the 2 and the 2, you can just cancel them out. Okay, so it's sinh over cosh. And these are the same as trig, right? Hyperbolic cosecant is the reciprocal of sinh. Hyperbolic secant, reciprocal of cosh. And hyperbolic cotangent, coth, is cosh over sinh, or reciprocal of hyperbolic tangent. Okay, don't worry about the graphs. They give you the graphs. I'm not holding responsible for the graphs. Okay, page 260 has identities. Don't worry about any of the identities, although you may have to prove some of these identities. Remember how you had identities in trig, right? You got them here also. Okay, so they're there. You don't really have to write them down. You don't have to memorize it. So if we were meeting face to face, I would still say don't memorize them or anything, but be ready to use it. You might have to prove it. In fact, some of the problems are proofs. Remember you did trig identities? So we have some identity problems here also. And then the derivatives on page 261. The only derivatives I want you to know are these: sinh, cosh, and hyperbolic tangent. So you can put these on your cheat sheet. But a lot of these kind of look like they were in trig also. Okay, derivative of sinh is cosh. That's kind of like trig. Derivative of sine is cosine. But look at this. Remember, what was the derivative of cosine? Not sine, but negative sine. But for cosh, derivative of cosh is sinh. So they're derivatives of each other. Derivative of sinh is cosh, derivative of cosh is sinh. And look at this. That's exactly like trig, right? Derivative of hyperbolic tangent is hyperbolic secant squared. Okay, and by the way, how would you prove these? They're very easy. You actually just do the derivative, right? So if you actually took the derivative of this, work it all out, you get that. And then if you took the derivative of that, work it all out, you get that back. Okay, in fact, there's an exercise involving that later on that you might want to do. Okay, and I don't need you to know these. Okay, so totally forget about them. They're correct, but they're so infrequently used, I'd say don't even worry about it. Okay, so never mind about derivative of hyperbolic secant, cosecant, and cotangent. Never mind about these. Okay, and never mind about any of the other ones. Okay, so we're not going to do very much. Well, I take it back. We're going to do a little bit of inverse hyperbolics. They exist. Okay, so I'll just talk very little about maybe 1 or 2 problems with that, and never mind about any of the others. Okay, so 262 has some stuff. Forget about that. They have their derivatives. Never mind about that. I mean, you can really dig deep on some of this stuff. 263. So don't worry about any of those derivatives. Looks like the inverse hyperbolics, right? All right, so I've given you everything you need for the cheat sheet in preparation for the test. Okay, so it looks like we're just about out of time. So tomorrow I'll get started with 3.10 and go from there. And I won't get that far because I have to give you time for the quiz. So remember, for the quiz for tomorrow, it'll be on exponential growth and decay. So I'll introduce 3.10. So I'm a little bit ahead, I guess. I won't get that far, and then I'll give you the quiz there. Okay. All right. So I think we're just about out of time today, folks. So that'll do it for today. So everybody have a good day, and we'll see you next time. Okay. All right. Bye, everybody.